Hello everybody, hope you're all doing great. This is Soshiance. In this video I'm configuring the spanning tree, also Per-VLAN Spanning Tree or PVST, and finally we'll have a look on EtherChannel. Simply to explain what is a spanning tree, you can say it is a protocol which avoids loops in a network with several redundancy. Simply the main task which spanning tree is doing is to activate the alternative option whenever the root or the main option is down for any reason. Let's move on to the diagram. In order to save time, I have already designed the diagram. You can see here we have 5 switches, 2 multi-layer switches and 3 normal switches or layer 2. By default, when you connect all the switches, so one of the switches will be selected as the root switch and one of the switches will be selected as the backup switch. Now you can see one of these ports are down, one of these ports are down. So we can say that this switch is selected as the main switch or the root switch. Let's go and check it out. Okay. Let's make some configuration. And let's change the name. Host name should be core switch 1. Now if I type show spanning tree, you can see here this reaches the root. So this is the root bridge, and whenever for any reason, why this is the root bridge, we can say about the priority. This switch is with the lowest priority. If you want, for example, you don't want this one as the root switch, you want this switch as the root switch, just you can configure that one. Simply you can decrease the priority. And as well configure, first of all let's check show spanning tree. You can see here it is the cost is full. It means this is not the root bridge, and in order to transfer the data to the root bridge, the cost will be false. So now we are configuring this one as the root bridge. Configure terminal. First of all, let's give a host name core switch 2, and simply you can go spanning tree VLAN. By default all the interfaces belongs to VLAN 1, and now we are just specifying the priority should be the priority. Now we are just giving a number. You can give a number between 0 to 61,440, and the increment is 4096. So we just give this one 4096. Now you can see by default these ports will be down and this port will be up. Why? Because we selected this one as the root bridge. This one is up, this one, and just it will take around 50 seconds. Now this one is as the root switch. Okay, now what we are doing is one thing, remember that all the interfaces which are connected point to point between the switches, they should be tranned. Now I go to this switch, and first of all I go to this one, and I make all the interfaces trunk. Not all of them, all the interfaces which are connected to other switches. Like first Ethernet 0 over 1, 0 over 2, and 0 over 3. Also give Ethernet 0 over 1, give Ethernet 0 over 2. I go to global configuration mode, and I'm selecting the interfaces, interface range, pass Ethernet 0 over 1 to 3. Give it an 0 over 1 to 2. Switch port. Since this is a multi-layer switch, first of all we need to specify, we need to encapsulate this and make that one queue. mode trunk. Now if I type show interface trunk, you can see these are our trunk interfaces. Now gig Ethernet 0/1 is not okay. Let's make that one as well. Show interface trunk. Configure terminal interface. Gig Ethernet 0/1. Switch port trunk encapsulation .1q. Switch port mode trunk. Show interface trunk. Okay, now we have all 5 interfaces which are connected to our switch on trunk, and the encapsulation is 802.1q. Same case with this switch. I should go and I should make the interfaces trunk. Configure terminal. Okay, fast Ethernet 0/1, 2, 3, same case interface range fast. Interface range fast Ethernet 0/1, 2, 3, gig Ethernet 0/1, 2, 2. Switch port trunk encapsulation .1q. Switch port mode trunk. Show interface trunk. These are our trunk interfaces. This interface. Okay, let me go to this one. Switch A. In switch A we are just fast Ethernet 0/1 and fast Ethernet 0/2 will be trunk. Enable. Configure terminal. Give a host name. Host name should be switch A. And interface range fast Ethernet 0/1, 2, 2. Switch port mode trunk. Show interface trunk. These 2 interfaces. Same case to this router. Switch. Enable. Configure terminal. Hostname switch B. Interface range fast Ethernet 0/1, 0/2, 2, 3. These 2 interfaces. Switch port mode trunk. Show interface trunk. Yes, our trunk interfaces. And this one 3 and 4. Enable. Configure terminal. Let's give a host name switch C. Interface fast Ethernet 0/3 and okay, interface 0/3. Interface range fast Ethernet 0/3, 2, 4. Switch port mode trunk. So interface trunk. Yeah, you can see fast Ethernet 0/3 and fast Ethernet 0/4. All of them are trunk. So we are done with the trunking. Now let's move on. Simply, this is the concept of spanning tree. When one side is down, one switch is down, another one will be up automatically. Now this one is the root switch. Whenever it's down, this side will be up automatically. Like let me just do it deliberately. I just shut down all the interfaces. Configure terminal. Interface range fast Ethernet 0/1 to 24, gig Ethernet 0/1 to 2, and I'm just saying shut down. Now just wait for after 50 seconds, like this. Yeah, you can see this side is down and this side will be up automatically, because this is the backup switch. This is what basically spanning tree means. Yeah. Okay, so let me just say no shutdown, so all the interfaces should be back. And now what we are doing is to make, you can see on each switch only one port is up at once. But now what we are doing, we are configuring the per-VLAN spanning tree. We have two VLANs. Up to now we have only one VLAN, VLAN 1 by default. We are going to create one more VLAN, one VLAN 20 and one VLAN 1, which is already created by default. And what we are doing is that just for one VLAN, for VLAN 20 for example, we are making this one as the root switch and this one as the backup switch. And for the VLAN 1, this one you can make as the root switch and this one as the backup switch. So at the same time, both interfaces will be up and the traffic will be balanced. The load will be balanced between all the switches, so we can use all our resources. We don't need that all the traffic should be routed through one switch. Okay, so now let's go and create the VLAN. First of all, let me show VLAN. We have only by default, this is VLAN 1 and all the ports belong to that one. Configure terminal. First of all, let's create make this one as the VTP server, so we don't need to create VLAN on all the switches. Okay, VTP. First of all, we need to specify version 2 is better, and VTP domain, you can just give a name, let's say domain.com, VTP mode. Okay, this one should be server. VTP password can be Cisco. And now if I type show VTP status, okay, and this is domain.com. Now I'll go to another one. Terminal VTP. Let's see, show VTP status. This one is also server, but it has identified the domain. Okay, now we should make this one as a client, because in one broadcast domain there can be only one VTP server. Configure terminal, VTP version 2, VTP domain, not domain, VTP mode, you can see this one can be client, and VTP password can be Cisco. Same case with this one. Configure terminal, VTP version 2, VTP mode, client, VTP password. Okay, and this one configure terminal, VTP version 2, VTP mode client, VTP password, Cisco. VTP version 2, VTP mode client, VTP password. Okay, so now I go to this core switch 2, which is our main switch, our root switch for now. Show VTP status. Okay, now I'm just creating the VLAN 20, configure terminal, VLAN, give a number, let's say VLAN 20, and you can give a name also can be VLAN 20, and now let's go and check on another one, show VLAN. Yeah, you can see we have VLAN 20 here as well, because we have these are the other switches are the client switch, so the VLAN will be created by default when we are creating on the main switch. Okay, let's go to the core switch 2. Okay, we are inside the VLAN, and now we are just specifying the interfaces to, we are dedicating the interfaces to VLAN 20. Let me exit from this mode and interface range fast Ethernet 0 over 13 to 24. From 1 to 12 will belong to VLAN 1, and from 13 to 24 will belong to VLAN 20. Interface range, okay, and first of all, interface switchboard mode, it can be accessed. Switchboard you can access this one, so VLAN 20. Let's click show VLAN. You can see VLAN 20, and okay, and now let's go to all the other switches. Show VLAN, and let's specify the interfaces. Configure terminal, interface range, Ethernet 0 over 13 to 24, switchboard mode access, switchboard access, VLAN 20. Show VLAN. Okay, now let's go to switch B. Configure terminal, interface range fast Ethernet 0 over 13 to 24, switchboard mode access, switchboard access, VLAN 20 for VLAN. Okay, and this one, core switch is done, switch A and core switch 1 is left. Show VLAN, we have VLAN 20, but the interfaces are not used, very too. Configure terminal, interface, range, fast Ethernet 0 over 13 to 24, switchboard mode access, switchboard access on VLAN 20. Okay, and the last one, core switch 1 is left. interface range fast Ethernet. 0/13 to 24 switchboard mode access switchboard access VLAN 20. Show VLAN. Okay. Now we created the VLAN and then dedicated specific interfaces to specific VLANs. Now what we are doing is since there are different VLANs, so we need to say the IP routing on both core switches, because all the routes, all the packets, all the data will be transferred, will be routed through these two main switches. And since there are two different networks, so we should say IP routing. Okay, IP routing. Okay, first of all, let's give IP address to our VLANs. Configure terminal. Oh no, I need to go to core switch 2. Configure terminal. And I'm just creating an interface for VLAN 1. No shutdown, and I'm giving the IP address. For the VLAN 1, we can give this IP address 192.168.1.10, 192.168.1.10, 255.255.255.0, interface VLAN 20. Shutdown, that's already up. And IP address, this one can be 192.168.20.10, 192.168.20.10, 255.255.255.0. Now if we type show IP interface B, you can see these are our two interfaces. Configure terminal, and now we can just type the IP routing. So it will be route. Now let's go and check the connection. I go from one of these PCs. I guess I have already assigned the IP address. IP config. Yeah, this is PC1. The IP address is 192.168.1.1 and belongs to VLAN 1, and this is the default gateway. Now let's ping 192.168.1.10. First of all, the default gateway, we are receiving reply. And now let's ping another PC from the same VLAN, we are receiving a reply. And if we ping 20.1, another VLAN, and we're receiving reply. How does it work is like when you ping from this one, the packets will go to this one, and from this one will be redirected to any of this, because this is the root switch up to now. But still, we didn't specify this one should be from for VLAN 1, and this one should be for VLAN. This one should be for VLAN 1 root switch, and this one will be for VLAN 20. So now let's go and do it. I go to core switch 2. Core switch 2, which is currently the root switch for all of our VLANs, for both of our VLANs. Now I just go to this one, configure terminal. We are already in the global configuration mode, and I'm taking spanning tree. Here we have something is spanning tree mode. We have PVST, Per-VLAN Spanning Tree. So I'm just selecting this one, PVST. Again, I'm typing spanning tree VLAN let's say this one should be for VLAN 20, VLAN 20, and I'm just typing bridge primary. So for VLAN spanning tree, for VLAN 20, this one will be the root, the primary. So that's all. And now I go to core switch 1 and I configure terminal, go to global configuration mode, and I'm typing the spanning tree mode. Mode should be PVST, Per-VLAN Spanning Tree, Spanning Tree, VLAN, this one should be for VLAN 1, and the root should be primary. So for VLAN 1, core switch 1 is the root switch, and for VLAN 2 is the core switch, for VLAN 20, core switch 2 is the root switch. Okay, now if we check the connections, for the VLAN 20, all the packets will be routed through this switch, and for the VLAN 1, all the traffic will be routed through this one. But except in this root switch, for VLAN 1, you should give the IP address as well. Core switch 1 and show VLAN, show interface, show IP interface 2. You can see we should create the IP address for each VLAN, and we should say IP routing, configure terminal, interface range, interface VLAN 1, may shut down, IP address 192.168.1.10, 255.255.255.255. We just assign the same IP address, so one side is down and one side is up, so at the same time both sides is not down for VLAN 1, so that it doesn't matter. Maybe now you will see a kind of a notification about the duplication of IP address, but that's okay. And exit interface VLAN 20, no shutdown, IP address 192.168.20.10, 255.255.255.0. Now okay, wait, I forgot to say the IP routing since they are different networks. Okay, show IP interface. So it's done. Now what happens for VLAN 20? All the route, everything will be routed through this one. And this is the root switch, and this is the backup switch. And for the VLAN 1, this is the root, and this is the backup. So whenever for the VLAN 1, let's say if the root switch is down, then the backup switch will be automatically up. Or let's say not the switch, maybe this interface is down, then automatically this interface, which is the backup one, will be up. Same case for this one. If this interface, if there's something wrong with the interface, something is wrong with the cable, for any reason, something is wrong with the switch, for any reason, when this path is down, this interface will be up automatically. This is what Per-VLAN Spanning Tree is doing. And one last thing, just I want to explain. That is the EtherChannel. EtherChannel. Now you can see here we have connected these two switches using two big interfaces. So for increasing the speed between two switches, for increasing the bandwidth, you can use you can connect several interfaces, you can connect several cables, but you bundle them as one. So now we didn't configure the EtherChannel, but now we are going to configure the Ether channel, and we are making these two interfaces to act as one. These two cables which we connected will act as one. In that case, so the speed, the bandwidth will be increased by 2. Okay, now I go to root switch, core switch 2, and I'm just selecting the interface, configure terminal, interface, these two interface, bigger than a 0 or 1 and bigger than a interface range, bigger than a 0 over 1 and 2. I'm just selecting the specific interfaces, and now what I'm supposed to do is to channel group. To channel group. And now we are just giving a number, channel group, let's say 1, and we are typing mode. The mode, one side in here, just simply one side can be active, or one side can be U2, another side can be desirable. You can say this side can be U2. Okay, now I go to core switch 1, configure terminal, interface range Gigabit 0 over 2 over 1 to 2, channel group, we're just giving a number, let's say 10 or 20, and the mode can be desirable. So now these two interfaces, it's down for a moment and it will be up, will act as one big cable with will act as one interface with higher bandwidth and speed. Yeah, the interface will stay to down and then it will be up. Yes, that's done. And now if you type show EtherChannel summary, you can see the related details. This is the number we created, and this is the other details. We have pack P, the protocol type, and the interface Gigabit 0 over 1 and Gigabit 0 over 2. And yeah, this is all about this video. I hope that is useful, and please, if it is useful, just like the video and subscribe as well. And for more videos and for more information regarding our activities, you can visit our website. And if there is any question, comment below. I will be happy to respond. And thank you very much. Have a great day ahead.